Okay, all right. So now, right off the bat, today might be one of the really long videos, or it might be surprisingly short. Okay, I've never actually done this before, so we'll see how it goes. All right. The topic, it's an introduction to something that's actually something that can be quite complicated. Okay, but so let's see what it looks like. Okay, all right. Okay, all right. So before we start that particular topic, I just want to kind of review and just show you how far we've come when it comes to doing these sort of questions. Okay, so with particular focus on the quadratic formula and parabolas, right? So now here, let's talk about all the things we've learned. So one of the things I wanted to show you, right, at the beginning, or the analogy I wanted to use was something like a bag of tricks, right? So another way to visualize this is kind of like a toolbox, right? So for example, right, for the GCF one, what we did was something like this, right? So if I showed you, I don't know, like 27x squared plus 3x, right? Can you factor this out using the greatest common factor, right? So something like that, like this, right? And then when we did something like unfoil, meaning like turning a, what, turning a, turning a trinomial, right, into two factors, right, like that. When we're doing taking square roots, right, we were talking about something like this, I think, all right? Maybe something like this, and then you have to take the square root on both sides, right? Perfect square factoring, right, was something like this. If I show you this, can you actually recognize that this is just this, right? Difference of squares. So if you see this, right, do you know that that's actually this, right? Completing the square. Let's see. By the way, if you want to make a graphic organizer for yourself and just kind of like list all these, like, so like, you can call it the toolbox, right? And then you could like name this one, GCF2, and look, I've just given you all the examples. I think that's a good way for you to kind of summarize everything you've done, okay? I might actually do this in class with you guys. We'll see. Completing the square, right? We literally just did it, so I'm not gonna write anything for completing the square. You can just look at your notebooks from yesterday, all right? And lastly, the quadratic formula. Remember the sledgehammer the analogy I use, right? So we're gonna do that, but not today, the day after, all right? Which is tomorrow, by the way, the day after today, right? Tomorrow we're gonna do the quadratic formula. So what are we doing today, right? Great segue, very great segue, all right? The discriminant, all right? So the discriminant, the word itself, right, just means how to tell one thing from another, okay? So what is this? Now, I'm gonna just, show you, right? I'm just gonna show you again the sledgehammer, that is the quadratic formula, all right? And I'm gonna write it on the side, all right? So this is the quadratic formula. So the quadratic formula is this, all right? Negative b, okay, this is a lot, just brace yourself, all right? Negative b plus or minus the square root, all right, of b squared minus 4ac, and put the whole thing over 2 times a, all right? Now, I know, it's a lot, okay? It's crazy, okay? But when I was your age, that's what I had to do. I had to memorize this, okay? Because I don't remember if they gave us that on the regions 30 years ago, all right? Now, so one of the things I wanted to do is not, drop this whole formula on you in one go. So I'm gonna, break it down to bits and pieces, all right, and just kind of help you digest this, okay? So now, the thing that we're gonna focus on, and another thing about the quadratic formula is it's a last resort for us to solve for a pair of solutions, okay? So you know how like when we were factoring a trinomial, so let me go back. Remember there are times when you cannot Remember times when you cannot factor this, right? Remember that worksheet where like, I think it was number 8, all right, I still remember, right? Where it says, where I told you guys to factor, and turns out you actually cannot factor it. Like there's no numbers that multiply to 4, whatever the numbers are. Obviously this is not the question to use, but like it doesn't multiply and doesn't add, right? You can't find the 2 numbers, right? And then I said also, if that's the case, then try the difference of squares, right? And if that doesn't work, then now you really got to, drop the hammer, all right, like Thor, and use the quadratic formula. Like you're guaranteed an answer, okay? It's very cumbersome to use. It's not great, all right? But sometimes, you need a screwdriver, and sometimes the only way you can get through anything is by using a sledgehammer, all right? And that's kind of what we're looking at, all right? Now, having said that, then I want to put our focus today on this, all right? So this is the quadratic formula. Like this is like Thor's hammer, okay? And so what we're going to do then is we're just gonna focus on what's inside the radical right here, this part where it says b squared minus 4ac, okay? Now, why is that helpful, okay? Because when we look at this, it will tell us a little bit about what the graph will look like. Remember again why we're doing this. It's because we don't want to graph it. We want an algebraic solution to a quadratic problem, okay? We don't have a graphical solution right now. We do, it's called graphing calculator, but you understand what I'm saying, right? If we choose to not use a graphing calculator. So what's a discriminant? A discriminant tells us a few things, okay? And I'm gonna highlight this for you, all right? So a discriminant can be used to determine the number and the type of solutions, okay, to a quadratic equation. I wish I can highlight that better, all right? Meaning, right, now every quadratic formula has 0, 1, or 2 solutions, right? So for example, again, let's look at it graphically for a second, right? So here we got our good old standard graph that I've been using for like 2 months now, right? So have you noticed for this question, there are 2 solutions, right? We got one here and one here, right? So that's a 2-solution quadratic function, right? And if you were to factor this, and again, the equation is not gonna be accurate, all right? Because I'm kind of doing this on the fly a little bit, right? You would get something like this, probably, actually I could just do this in my mind right now. Okay, this is x plus, what is this, x minus 3, and that's x plus 1, right? And then I FOIL it, x squared minus 2x minus 3. I believe that this is it. Am I right? Okay, I could be wrong. All right, now, hold on 1 second. All right, okay, I checked that it's true. Yeah, I just did it in my head. I actually, okay, all right, I'll think out loud for a second, right? So what I did was I actually just wanted to see, like, if my guess that this would be the equation for this graph is true, because I did the negative b over 2a, remember that, to get the axis of symmetry, all that, and I plugged it in and found out the vertex. So everything's cool. All right, good. Now, where were we? So here, right, you can see that here we got 2 answers here, right? So for this quadratic formula, we get a curve that get 2 x-intercepts, and therefore really what it means is 2 solutions, right? And not only that, we get 2 solutions that are actual numbers, right? Like they're actually like whole numbers, they're integers, right? Got that? Now, that's your 2 solution sort of graph, okay? So what would a 1 solution graph look like? All right, so let me erase all of this, okay? So what would a 1 solution graph look like? Let me make a curve then, all right? I think this will do. Yeah, there we go. Man, I'm a genius. All right, okay, so now a 1 solution graph might look something like this, where it's just touching in one spot here, okay? Or even, so even, hold on, the light just went out. So so for example, remember a parent function, right? A super basic quadratic functions, y equals x squared, right? So that one would look something like this, all right? Where the solution is at 0, like where the solution is also a vertex, right? At 0, 0. So hold on, let's see, what do I need? Oh, I need a highlighter. right? Like right here, there's your solution, right? One solution, right? So that would be like a parent function, like I just alluded to. Now, what would a no solution, right? Because that was one solution that we were talking about. So what does a zero solution look like? A zero solution, hold on. So a zero solution answer would be something like this, where the graph not even touching the x-axis. Okay, you see that, right? It could be up here, it could be over here, it could turn upside down like this, and then like, you know, down here somewhere, right? So that's a zero solution question, okay? Now, having said that, all right, what do the numbers look like? All right, hold on. Oh, one more thing before we move on. If you have a, hold on. If you have a graph that has no solution here, your answer is not even gonna be a real number. And what does that mean? It's gonna be an imaginary number, okay? That number doesn't even really exist, okay? Which is kind of crazy, and it's also a 10th, 11th grade topic, but we'll get to that, okay? We're not gonna spend that much time on imaginary numbers, okay? Not on regions. All right, now, so having said that, right? So I'm just gonna show you some examples and what the graphs look like, okay? So this is, hopefully this is not gonna be any longer than 20 minutes today, okay? Now, let's see. So if you get an answer, all right, and we're only gonna spend one day on this because I don't wanna spend that much time, all right, on this topic, because I could only find 3 regions questions on this, and I'll show you all 3, okay? Now, that said, right, if your discriminant is negative, oops, I thought that was a highlighter. All right, if your discriminant, all right, you might have to take a little bit of notes, okay? You don't have to write everything, but, all right, if the discriminant, you should write this, all right? If the discriminant is negative, meaning this. So look at this example, right? So for this one, right, b squared, so a is 1 here, right? Now, remember when we did that exercise where I asked you, do you know your A, B's, and C's, right? That's really what this is for. Like, this is like the grand finale of that whole exercise, okay? So, right, so b squared minus 4ac, right? So b squared, 2 squared, I'm just redoing the math, okay? Minus 4ac, like that, 4 times a times c, okay? And that you will get negative 16, right? That negative number, now that negative number in itself doesn't really do anything, because that's not the real answer, okay? It's just that by looking at the type of answer, what types, positive or negative, all right? Whether there's perfect square or not, okay? It will tell you the kind of answer you're gonna get, not the what, but you know, well, it is the what. Not the actual answer itself, but what the solutions will be. Will they have 2 solutions? Will you get 1 solution only? We have no solutions, okay? Are you gonna get decimals, or are you gonna get whole numbers, or are you gonna get imaginary numbers, okay? So it's a lot, okay? I know it's a lot. All right, you know what? I should write that down, all right? So here are the possibilities. You can get 2 solutions. You can get 1 solution. You get no solution, right? 0 solution, actually, all right, to be more accurate. And then the kind of numbers that you can get are integers, like good old whole numbers, right? Positive and negative whole numbers, including 0, right? You can get decimals, right? Which includes radicals. Because square root of 3, for example, right? It's a decimal, right? And then lastly, you can get imaginary numbers. All right, meaning the letter I. Okay, that's a letter I. All right, so those are the kind of possibilities. All right, so let's explore which one's gonna be which. Now, if you get a negative answer like this, right? Like how we got negative 16. I shouldn't say negative answer. It's not an answer, really. It's a negative value. How about that? All right. So if the value of the discriminant is negative, then you have two imaginary number solutions, okay? So you're gonna get a graph that looks like this. It's gonna be completely lifted up, like it's not grounded. I mean, here's a way to help you remember this. It's not grounded in reality. It's not sitting on the x-axis anymore. It's completely lifted away, okay? Got that? So it's imaginary, right? When it's not grounded in reality, right? So that's the first thing. Second, if you get a 0, so for example, if we use this as an example, right, and you do b squared minus 4ac, and your answer comes out to 0, again, your value comes out to 0, then you're gonna have one answer, okay? So kind of like the parent function also, right? Like where you get only one answer, same thing, okay? So the graph will only touch the x-axis and one and only one point, okay? And you'll get a graph that looks like this, where the solution is here, okay? All right? Lastly, if it's positive, there are two cases, all right? So there are 3a, all right? There are two things that can happen. If it's more than positive, is more than 0, okay? So for example, looking at this equation, right? And your value ends up, right, being 25, or perfect square. So what's a perfect square? So 4, let's see, 9, 16, 25, you know, like 100, right? If you get those, you're gonna get two things, all right? One is you're gonna get yourself a two solution answer where the graph goes through 2 points on the x-axis, and your answer, now, although the answer is not 25, your answer is gonna come out as a whole number, okay? So for example, I can prove this. If I take this and I factor it, you're gonna get two answers. Look, right? So let's see. This is -4. So what is that? 4. Hold on. Let's see. 4 and 1. 4 times 1 is 4. Yeah. Right. The positive goes to the 4 negative. Yeah, that's right. Yep. 4x minus 1x. Yep. Right. So you get this. Right. So the solution is x is -4 and x is +1, right? As you see in the graph here. Okay, got that? All right, again, positive answer, positive values. It gives you, not only does it give you two roots, two solutions, it also, those two solutions are also integers, okay? Like no decimals, okay? And then the second potential, all right, for 3b is if it's positive, but it's just any old regular number that's not a perfect square, like a 17, for example, you're gonna have two roots like this, but I don't know if you can see this, but if you look closely, these aren't whole numbers. You're gonna get decimals, okay? So if the value is positive, but not a perfect square, you're gonna get two real number solutions, all right? Now, what else should I say? I think I should leave it at this, actually. Okay, now let's take a look at three regions questions. Okay, now, just before we do that, I just want to point this out. If you see a question like this anywhere, all right, you can't just start doing b squared minus 4ac for this guy, because you gotta make sure that you add the 3 back. So this is -p squared plus 4p minus 4, yeah, equals 0. Then you could use this b squared minus 4ac to evaluate this. Okay, all right. I know I'm going a little fast, so I'll try to. I mean, we're in class. I could spend more time explaining this, and if not, then I think you guys might have to just do more delta math questions. Okay, all right. So how many real number solutions does this have? Let's try it. Let's use what we learned today. B squared minus 4ac. So let's see what's a. Let me list that out. A is 4. B is 2, C is 5, right? So B squared is 2 squared minus 4 times A times C, right? So 2 squared is 4 minus 4, oh, it's gonna be a negative answer, isn't it? Let's see. 4 is 16, 16 times 5 is 80, right? So that's negative 76. I just gotta double check. B squared minus 4AC, right? B2 squared minus 4 times A times C. Yeah, so you're gonna have 0 solutions. Okay? Your answer is gonna be imaginary. Now, what does that mean? That means by the time you use the quadratic formula tomorrow, you're gonna get a negative square root, which, by the way, is a big no-no. Like, it doesn't happen. You can't take a square root of a negative number, all right? We talked about that, like, back in September, probably. All right? Okay, 14. How many real solutions does this have? Okay, let's try again. All right? B squared minus 4AC. You know this is how I keep rewriting it, right? So what's A? A is 1, B is negative 2, C is 5, so B squared, so negative 2 squared minus 4 times 1 times 5. 4AC, hold on, let's see, negative 2 squared is 4, right, yep, 4 minus, and then 4 times 1 is 4 times 5 is 20, so that's negative 16, right? So again, none. All right, that's 0 real solutions because, all right, because B slash C, because the discriminant, okay, it's my end, discriminant is negative, right? Again, right, what do I say, right? A negative discriminant, right, has no, there are 2 imaginary number solutions, right? No real solutions, basically, right? Let's see, what else do I have to talk about? Lastly, is the solution written rational or irrational? Okay, so meaning, is it gonna be, okay, let's answer this first, okay? All right, let's see, A is 2, B is 3, C is negative 10, right? So B squared minus 4AC, so that's 3 squared minus 4 times 2 times negative 10. I have a feeling it's going to be this gigantic positive number. Let's see. 3 squared is 9 minus, let's see, 4 times 2 is 8. 8 times negative 10 is negative 80. So that's 89. So that's positive. But your answer, since it's not a perfect square, if it's not a perfect square, you're going to get an irrational answer. Rational in this case means like, hey, are you going to get a perfect square? Are you going to get an actual like non-square root number? Think of it like that. Okay, so there you go, all right? So it's gonna be irrational answer because the discriminant is an 89 and it's not a perfect square, okay? Hold on, let me double check something. All right, so yeah, I just had to double check with the answer key, okay? And everything I said is absolutely true, so, all right? So that's it, all right? Let's sign off. Tomorrow we're gonna really get into the really deep stuff, okay, with the quadratic formula, all right? And we're gonna spend 3 days on that, okay? So, yeah, hopefully if you find this lesson manageable, right, with the B squared minus 4AC, I think you guys are gonna be okay for tomorrow, okay? All right, thanks for watching, all right? Thanks for being so patient. Have a good day, and I will see you tomorrow. Okay, all right, bye-bye. OMG, that was so good.